Hello everyone, welcome to this tutorial. In this video we are going to see how to solve an equation involving trigonometric functions. In this video we're gonna solve these four equations on a given interval 0 to 2 pi. Let's start from the first equation. The first equation is to find the value of x so that sine x minus pi over 2 equal to radical 3 over 2. To make it simple, let's let this inner part by y. So let y equal to x minus pi over 2. Then we can rewrite this equation as sine y equal to radical 3 over 2. It means finding a value of y so that its sine value is root 3 over 2. In other words, we can write this one as sine inverse of root 3 over 2 or arc sine of root 3 over 2. Then, from previous lessons, we know that the sine value of 60 degree is root 3 over 2. Since these trigonometric equations have infinite solutions, basically sine will cross root 3 over 2 in one full cycle. So we need to find the quadrant in which this sine value have positive values. Sine will be positive in quadrant 1 and 2. Simply you can remember using all students take chemistry as we did before. All sine, cos and tan will be positive in quadrant 1. In quadrant 2, all students means sine will be positive while tan and cos is negative. And in quadrant 3, tan is positive and sine and cos will be negative. In quadrant 4, cos is positive while sine and tan are negatives. So after getting a reference value of 60 degree, we will find a value in quadrant 2 so that it have a reference value of 60 degree. So using simple drawing, you can find an angle whose reference value is 60 degree in quadrant 2, and it will be 120 degree because we measure in counterclockwise direction. Thus y equal to sine inverse of root 3 over 2 will have two solutions in one full cycle, which is 60 degree in quadrant 1 and in quadrant 2 it have 120 degree. Changing this value in radians, it gives pi over 3 and 2 pi over 3. However, since sine functions is a periodic function with 2 pi, a general solution for this equation can be written as y equal to pi over 3 plus 2n pi and y equal to 2 pi over 3 plus 2n pi, where n is given by 0 plus or minus 1 plus or minus 2 and so on. The question is to find x, not y. So let's substitute back y by x minus pi over 2, since the question is sine of x minus pi over 2. So substituting back y by x minus pi over 2, it gives, because this y have a value of pi over 3 plus 2n pi, thus x would be this side, it will be plus, so pi over 2 plus pi over 3 plus 2n pi, and for this one it will be pi over 2 plus 2 pi over 3 plus 2n pi. Then find a value of x by changing the value of n. Start from 0. So substitute 0 here, it gives 5 pi over 6, and here it gives 7 pi over 6. For n equal to 1, it gives x equal to 17 pi over 6, or here it gives 19 pi over 6. Thus, from the sets of values, we will select the value which are in our domain. Remember, our domain is from 0 to 2 pi. So the only solution in our domain will be 5 pi over 6 and 7 pi over 6 are the solutions for the equation. Now let's do the second question. The second question is tan of x over 3 plus 2 pi over 5 equal to minus root 3. As usual, let's let this inner part by y, and then we can simply write this one as tan y equal to minus root 3. It means find the value of y so that its tan value is minus root 3. From previous lessons, you know that tan value of root 3 is for an angle of 60 degree. So after getting the 60 degree, we will find the signs and the quadrants. Since here is negative sign, so tan will be negative in quadrant 2 and 4. So we know the reference value is 60 degree, and we know the quadrant. Then we will measure an angle which have a reference value of 60 degree in quadrant 2. It means we will get 120 degree, and in quadrant 4 we will get minus 60 degree. Minus 60 degree because we measure in clockwise direction. Thus tan is periodic with pi. So after getting one solutions only on the interval of pi minus pi over 2 and pi over 2, we can write the general form of y as y equal to y1 plus n pi. For our case, minus pi over 3 is in the range of minus pi over 2 and pi over 2, so we can write a general form of y as minus pi over 3 plus n pi. This 2 pi over 3 can be found by letting n equal to 1, where n is 1 minus pi over 3 plus pi, it gives 2 pi over 3. That's why tan is a periodic functions with pi. After getting this the general solutions for y, make a substitution of y by x over 3 plus 2 pi over 3 and solve for x, because the question is to find x rather than y. So finding the value of x from this equation gives minus 11 pi over 5 plus 3n pi. Then find a solutions of x by changing the value of n. For example, for n equal to 0, it gives x equal to minus 11 pi over 5. For n equal to 1, it gives 4 pi over 5. And for n equal to 2, it gives 19 pi over 5. For n equal to 3, 34 pi over 5. And we can list infinite solutions. From this list of solutions, we will select our solution which are in our domain. Remember, our domain is 0 to 2 pi. So the only solution in our domain will be 4 pi over 3. 4 pi over 5 will be the solution for x. Let's proceed to the next question. The next question is sec of x plus pi over 4 equal to minus radical 2. Let's let y this inner part, so y equal to x plus pi over 4. Then we can simply write this equation as sec of y equal to minus radical 2. It means find the value of y so that the sec value is radical 2. As we know, sec is a reciprocal function of cosine, so 1 over cos. So 1 over cos of this value, it means 1 over radical 2. So 1 over radical 2 or root 2 over 2 is a trigonometric value for sine and cosine value of 45 degree from previous lessons. After getting this sec of 45 degree, it gives radical 2. Because this is the sign is negative, then we need to find out in which quadrant this is the value. So sec, it means they have the same value with that of cos, so cos is negative in quadrant 2 and 3. After finding out in which quadrant, we know that the reference value is 45 degrees. So in quadrant 2, finding an angle whose reference angle is 45 degrees is the same as measuring an angle of 135 degree. The same way in quadrant 3 we can find out a reference angle of 45 degree. In quadrant 3 means measuring in clockwise direction, it gives 100 and minus 135 degree, or in anti-clockwise direction you can get 225 degree. Then changing this value in radians, 135 degree means 3 pi over 4 and minus 135 degree means minus 3 pi over 4. So a general solution for this equation is the same as y equal to 2n pi, since they are the same number but different sign, so plus or minus 3 pi over 4, where n is 0, plus or minus 1, and plus or minus 2, and so on. After getting the general solution for y, as usual, substitute y by x plus pi over 4, the inner part of the equation, and solve for x. So x will be solved as 2n pi plus or minus 3 pi over 4. This goes to this opposite side, it will be minus pi over 4. Then get a value of x by changing the value of n. For example, for n equal to 0, x can be calculated pi over 2 or minus pi, because here there is plus or minus. So for this one is 0, the first will be plus, so 3 pi over 4 minus pi over 4, which gives pi over 2, and when it is minus 3 pi over 4 minus pi over 4, which gives minus pi. The same way for n equal to 1, x can be calculated 5 pi over 2 or pi, and for n equal to 2, x can be calculated as 9 pi over 2 or 3 pi. So from this list of solutions we will find which are in our domain. So the solutions in our domain will be pi over 2 and x equal to pi are the solutions in our interval. The last but not the least equation is cosec of 3x over 2 minus pi over 3 equal to 2, and having a constraint of cos x less than 0. First we will solve this equation, and after getting a solution of x we will find out which value of x are satisfied this constraint. So as usual, let's start by letting this inner part by y and simplify this equation as cosec y equal to 2. So finding a value of y is the same as cosec inverse of 2. Cosec, it is a reciprocal functions of sine, so sine have a value of 1 over 2 for 30 degree, so it means reciprocal of 1 over 2, it will be 2, so cosec inverse of 2 means 30 degree. After getting this reference value, since here it is positive, we need to find cosec where in which quadrant it is positive. So in quadrant 1 and 2, sine is positive, implies that cosec will be positive. So in quadrant 1 it will be 30 degree as it is a reference value, but in quadrant 2 having a reference value of 30 degree means 150 degree in quadrant 2. So changing this value in radian, it gives pi over 6 and 5 pi over 6. So it means since cosec is periodic functions as sine with that of 2 pi, then the general solution for y will be pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi, where n is given by as usual. Then substitute y by 3x over 2 minus pi over 3 in place of y. So substituting back this and find the value of x from this one, it gives x equal to 2 over 3 pi over 3 plus pi over 6 plus 2n pi, and this one. So simplify this one gives x equal to pi over 3 plus 4n pi over 3, and this one will be 7 pi over 9 plus 4n pi over 3. Then for n equal to 0, this will be pi over 3 and this one will be 7 pi over 9. For n equal to 1, when this is 1, x will be 5 pi over 3, and for this one is 1, it will be 19 pi over 9. From this list of infinite solutions for x, we will select which are in our domain. In our case, pi over 3 it is in our domain, 7 pi over 9 is in our domain, and 5 pi over 3 is in our domain, but this one is not in our domain. So from those three solutions, we will select which are satisfied by the constraint for cos x must be less than 0, meaning its cos value of x must be negative. For which value of x? We know that cos is negative in quadrant 2 and 3. So from this list of solutions, we must choose a solution which is in quadrant 2 and 3. This one, pi over 3, it means 60 degree, it is in quadrant 1. Pi over 9, this is greater than 90 degree and also less than 180 degree, so it is in quadrant 2. This one 1.33, so this one is in quadrant 4. This is not in our domain. So from this list of solutions, the only solution is 7 pi over 9. So x equal to 7 pi over 9 will be the only solution which satisfies both the constraint cos x less than 0, and it is also a solution for a given equation which is cosec of 3x over 2 minus pi over 2 which equal to 2. This is the way how we solve trigonometric equations. If you have doubt, please write on the comment. If you are new, please subscribe. It's enough for today. Goodbye.